We are going to spend some time working in the taxa summary sheet because this is the one that has most of the data that you can work with for your initial analyses. What I want to show you how to do is to play around with this a little bit. And one of the things that we'll do is, because there is so much data here, we'll make a couple of decisions to reduce the amount of data that we're going to look at, just to keep things easy when you're starting out with Excel, just so things don't get too complicated and files don't get too big. Now, one thing that is critical, and what I would do is, when you get this data file, save the original as the original and then make a copy that you can play around with, so that if things get messed up, you can always go back to that original file. So you could save this Excel file as original, and then you could copy it or save it as a test sheet that you're going to play around with, maybe with your initials, just to keep things organized. The other thing that you can do, and I'm going to do it right now, is copy the sheet so that within this Excel file I can play around with the data on one sheet without having to worry about, if I mess things up, then I can go back to the original sheet to get the data that hasn't been necessarily fooled around with yet. So what you can do is click down here, that's right click, and you can select move or copy, and I'm going to again select on taxa summary, create a copy, and then hit OK. And if you look down here, here is taxa summary 2 and the original taxa summary. And I think I can move that over to the end. And if I want, I can double click it and I can change the name to test, so that I know that this is the one that I'm manipulating, and that if I want to go back to the original, this one will be the original. Okay, so from working in this test tab, one of the first things that we may want to do is say we need a cutoff. We have 823 different OTUs. That's maybe more than what we want to look at, and let's reduce that. So maybe we're only looking at a couple hundred or less, and not have everything shown. So if we look over to column M, this is the average. And you can look here, this is the formula bar, and this shows you what was done to get the value that's in this cell, the cell in column M, row 2, so that would be cell M2. And you can see that the formula equals average of C2 through K2. And so if you look, C2 is the first sample A at 10 to the 3, K2 is 10 to the 5th of soil C, so there's a total of 9 samples there that have been averaged to give you the value there. And that value is, in this case, remember, if we're multiplying it by 100, 6.4%, which isn't particularly meaningful because we're summing across these 9 samples. And when we were looking in one sample, we could be sure that all the numbers in the column added up to 100, but now, because we're adding things together, that's not true. So this value is not particularly useful in terms of saying what it is as a percentage of everything, because if we sum all these up, it's going to add up to more than 100. Nonetheless, it does tell us which samples are highly represented in this data sheet. And for right now, you can ignore the ones for soil A, soil B, and soil C. If you look, these are just the sums of the values for the A set, B set, and C set, and not the average. Okay, so of course the average is going to sum up rows C2 through K2 and then divide by the number of entries, which would be 9. So if we take this average, this will tell us which ones are highly represented in the sample, and we can sort based on that. And let's just select everything up to average, and we'll go down, and you can see that it's going to take a little bit. There are shortcut keys where you can jump from one place to another, but it differs from Macs to PCs and so forth, so I'm not going to try to confuse you with those at the moment. But we're going to select all of the data so that we can sort based on the value that's in the averaged column that's averaged across all of the different samples. And again, you can see if you're on the left that we're scrolling down, we're to 500 now, so be to 800 soon. But again, one of the reasons we want to trim down the data is because it's kind of a pain in the butt to have to deal with all 800 entries if we're not necessarily concerned about, at least initially not concerned about those that are represented at very low levels. Okay, so we're getting close to the 823. So we have all the data that we're interested in selected. And I'm going to go up and go to the sort function. Yep. And I'm going to do a custom sort. And I'm going to choose my list has headers, okay, because I don't need to include row 1 in my data because that's just column identifiers, not the actual data. So you can see when I do that, the column identifiers are no longer selected. I can choose the column that I want, which remember is average, and I'm going to do it not from smallest to largest, but from largest to smallest. And I have to have everything sorted because I don't want to just sort the average column. I want all of this stuff to be sorted along with it. And I hit OK. And that's done the sort very quickly. And if we look over here, these values are now going to be in order of highest down to lowest. And we can now pick a cutoff value. Okay. And maybe we want that cutoff to be 0.5%. Okay, so remember that we're going to multiply these numbers by 100 to get the value. So if we were to look at this one, that would be 0.57%. So we're going to go down to 0.5%. So this one would be 0.5%, and the next one would be 0.499%. So we're going to just arbitrarily make that cutoff at, here it's going to be 50, so since the first row doesn't have anything, that's going to be 49 samples. Just to make it even, we'll keep the top 50. Okay, and so what I'm going to do now is I'm going to select all the others. And I'm going to delete all of that. I'm going to clear contents. Okay. So now I only have 50 entries, which makes things a little bit easier to work with. For the time being, I don't need these, so I'm going to get rid of them. Again, I'm going to go to clear contents, and that's gone too. So now I have a more manageable set here of 50 entries based on the 50 most abundant OTUs in the averaged samples. Okay, and we arbitrarily set the cutoff at 0.5%. And if we round this one up, that would be 0.5% as well. So that's fine. Okay. So let's begin with a couple of the things that you may want to start out doing with your data. Remember that these numbers are representing the relative abundance of each OTU in that sample, and in theory those should add up to 100%. But remember, we eliminated everything that was below 0.5%, so we want to see what percentage of the total still remains in our kind of cut down, in our trimmed data set. So we can do that by entering a formula here in this cell. We can go to the formula bar and we can do equal. We can type in one of the formulas, sum, and we're going to sum all the numbers in the column. We have to close the parentheses at the end of the formula, hit return, and now we have the summed value, which is essentially 74%. So of those top 50 that we looked at, 74% are represented there. That means that there is 26% of the data fell in a percentage that was less than our cutoff. So we'd like to be able to account for that. So we can enter in an other here. This is just going to be the other that was below our threshold. We can even put some information in there like less than 0.5%. Okay. And so how do we calculate that? Well, easily that's, again, putting in a formula. That would be 1 minus this value here. So again, about 26%. So we have that all for the first sample, soil A, and we'd like to copy that across to the other sample, so we can select it, and we can go to Edit, Copy, and select the region that we want to copy it to. Oops, not to there, but to there. So now we're going to copy what we did in column C across to columns D through K. And now we can just do paste. And there we nicely have all of that information that's all been copied over. We can check that we really got what we wanted. If we go here now, because we have this other, if we sum everything, that should equal 1. And let's select the, there we go. Close the parentheses out on the formula. Oop. And what did I do wrong? Sum C2 through C53. Oh, right. So we don't want to include this one because that's now we're double adding. So we're going to go to here, select this, and we're just going to move it up so we don't get that. So we don't count it twice, and now it adds up to 1, which is what we would expect. Okay, and you can see when I highlight this, it's nicely boxing in everything that we're summing. Okay, now that was just a check to show that everything we did was working, so we can get rid of that. We don't actually need to include that. That was just a double check for our purposes. And now we have that other, and we can now do some other manipulation